Okay, can you see the slide presentation? The pro forma, is it clear? Okay, thank you. Okay, this one is your teaching plan for the whole semester. Okay, we have here the formal method. Okay, and then this course is basically discuss techniques and tools. Basically, is a continuation from structure, discrete structure. And then we continue for the modeling and formal logic, and also the inferences that are being used to specify and verify the requirements, especially for designing the computer system. Okay. Okay, and then me myself, I am the your coordinator and also the only one teach formal methods. Okay, the semester and year offered is from year one, and semester offered since the semester two. Do we have the repeated student here? Do we have the repeated student here? Ada yang mengulang ke? Tak ada. Do we have any repeated student? Tak ada. Okay. Okay, we continue. Okay, we have four CLO, which means that we have four assessment. Okay, later I explain. Okay, the first one to outline the concept and features of formal method. This one we have online quiz. Online quiz basically we do the online quiz with my guru. My guru, and then I give you a certain time in my guru. You need to answer the quiz. Later I will explain to you. Okay, secondly, CLO number two to educate a formal specification where it's be written in formal languages. This one is individual assignment. You will give two individual assignments, and then to organize a practical application of formal method and its rule. This one is the final assessment. And then the last one, you work effectively as a part of a team, is a group assignment. Okay, for the group assignment, I think this one you need to have two or four people in a group assignment. Okay, okay. This one is the learning outcomes. Okay, you can read, communicate effectively. Okay, and then for the course content outline. Okay, first we have the overall overview of the formal method. First, I explain the pro forma. By today, we are going to have the overview of formal methods. What is formal methods? What is the advantages and disadvantages of formal method? And then we have some. I also explicate and explaining some supporting tools. Okay, later next week or later we discuss about our replacement class, because last week we have the Maulidur Rasul holiday, public holiday. Okay, we have a introduction to VDM, and then we have a VDM plus plus, and we have a VDM class structure. And then after that, we go for the Z notation. Z notation is the interchange languages and maximal set, and that also the data type. And then after that, we go back again for the logic. This one is the extension from your knowledge. Okay, from your knowledge from discrete structure. And then we have a notation, operators, and also quantifier, because in discrete structure you have learned lots of quantifiers. And then we go again by the logic. Okay, from week 5 to week 6. Okay, and then week 7 we go by the columnization, okay, CNF and resolution. Okay, and then we go by individual assignment 1, and then we go by the soundness and completeness. And then we discuss also the temporal logic. This one more on the applied application that been implemented in formal methods. Okay, and then we go by the assignment 2, and then presentation, online presentation. Okay, for the assessment, continuous assessment, distribution. As you can see here, for the quiz, online quiz is 15%, individual assignment is 20, group assignment 25, total up is 60 for the coursework. And then we have the final assessment. Final assessment is 40%. Altogether is 100%. Okay, and then special requirement none. Okay, and then this one is the references. Okay, later I will include all the references in my guru and also at the Padlet, in the Padlet. Okay, so far any question? Do you have any questions so far? Is it okay? Yuan Hobo, is it okay for you? Okay. Uh, okay, can we continue? If can you all type one? If we can continue, you type one in the chat. Okay. Do you have any questions so far for the perform or learning outcome? Is it achievable to get A? Okay. Okay. Now we looking for the first chapter of your formal methods. Okay. This one is ebooks that you can refer upon, but this one I will provide later for ebooks. Okay. Okay, for the introduction of formal methods, first we take a look of what is a formal method, the overview, how formal method can be implemented in the industrial, and then secondly we are looking for the definition of formal method. Okay, and then we go by the advantage and disadvantages. And then alternative, some formal method alternative. And then we are looking for the supporting tools. We go by the Java, okay, for object oriented. And then we go by the tools, supported tools for formal methods. Okay. Okay, so far, do you have any question? Do you have any question? Boleh? Apa? Okay, for formal methods tools, tools for formal method, uh, we have several tools for formal verification. For example, we have equivalency checking, assertion-based verification, and formal applications. Okay, this one is the tools that being used. And then for the supporting tools, we have formal and informal tools. Okay, supporting tool divided into two, formal and informal. Okay, later we discuss this one. Okay. Okay, this one is an overview of formal methods. Okay, this one is just a glimpse of review of formal methods. You need to know what is formal methods. Okay, okay, formal methods basically the system design technique. Okay, that use rigorously specified mathematical model. Okay, mathematical and logical model to build a software and hardware system. This one is just the overview of formal methods. In contrast to other design systems, formal methods are using mathematical proof as a complement to system testing in order to ensure the correct behavior. Okay, we are using mathematical and logical. Okay, this one. Okay, basically we are using system testing. System testing to ensure the system behavior. Okay, testing to ensure the system behavior. And then to ensure the system behavior, we need system verification. We need to verify, okay, verify the methods, the methods. Okay, okay. Why we use formal method? Do anyone knows why we must use the formal methods? Kenapa kita perlu guna formal method ni? Afiq ada Afiq? Muhammad Afiq? Afiq? Afiq, are you there? Muhammad Afiq? Hani Syahira ada? Ah. Okay, basically, why do we use the formal method? For what reason? Hani Syahira, ada jawapan ke? Okay, boleh diterima. Basically, for formal methods, why we use formal method? Firstly, the reason is to model a complex system. Complex system must use formal method. Okay, uh, because of the mathematical entities. Okay, okay. This one formal methods. We use the formal method because to model the complex system. Okay, model the complex system. That basically the complex system is associated with the mathematical model. Okay, that's why we have the mathematical and logical. Okay. Okay. What is formal method? Okay, this one is applied. Okay, applied. Ama ada Ama. Ama Ashraf ada. Oh, Ama ada ke Ama? Salah masuk ke? Ama ada? Oh, tak ada. Dia tak dengar. Okay. Okay, this one is we must use the formal method, yes, Conceptual, in order to have the systematic, in order to get the system more systematic and in order. Okay, okay, formal method can be applied for safety critical system. Why we must use a safety critical system? Why? Because the safety critical system is involving the life. Say for example, we have the aerospace, we have the automotive, and when we have the healthcare. What is the safety critical system for healthcare? Intubation machine. Intubation machine is using a formal method because it's very critical. Okay. Other than that, we have intensive care machine. Uh, okay. Other than that, for healthcare, uh, we have the machine to measure the heartbeat. Heartbeat is very critical, and also other than that, we go by the railways. Railways also very critical. This one is very safety critical system because it involves life saving. And then for automotive, we also have Tesla. Tesla introduced the autonomous driving, and this one is also using the formal method because it's safe, critical system that involving life. Okay. And then also aerospace, and then we have healthcare, okay, and then railways. Okay, secondly is for describing a complex system, very complex system. For example, complex system, we have IBM servers, and then we have the Facebook servers, and then we have algorithm for Google. Algorithm for Google is a very complex system, and then provide a program for development such as proof and model checking. Okay, proof and model checking is very common to formal method. Okay, model checking. In the scope of computer science, model checking or property checking is a method for checking whether a finite state model of a model system meet a given system requirements. Okay, model checking. Okay, model checking is abstract. Okay, model checking abstraction is more on the abstraction. More on the abstraction. Okay, more on the abstraction representation of the system. Okay, this one is basically proof and model checking is looking also for the system behavior. Okay, okay do you have any questions so far? Okay, dialysis is also true. Dialysis is a safety critical system. Other than that, heart monitoring system. very safety critical system. And then we have aerospace. Oh, tadi ada orang call, okay. Never mind. This one is formal method. Okay. Okay, this one is just a description. What is formal method? The system design technique. System design techniques. Okay, that use rigorously. Rigorously, which means that very to measure the complex system lah. Okay, specify mathematical model to build software. Okay, later we see what is software and then also the hardware system lah. Basically for the complex system, system design technique. Secondly, is use the mathematical proof as a complement to the system testing in order to ensure the correct behavior. Because before this, I have mentioned the correct behavior is important to the system because it acquire a lot of monetary aspect. This one correct behavior because to avoid losses, loss. Okay, avoid loss. Okay, and then formal method also referring to a variety mathematical modeling techniques then applicable to computer system design. Okay, we are looking for the computer system design. Okay, do you have any questions so far? Okay, what is a mathematical model example? What is the example of mathematical model? Okay, three mathematical model that you need to know in the formal method. First one is abstraction. Second one is heuristic and in silication. In silication, this one is three model that you need to know. Other than that, you need to know algorithm and also computational. Okay, this one is three types of model. Three type of model for mathematical model. Okay, mathematical modeling. Ini. Okay, besar sangat ni. Okay, we can have abstraction. Okay, and then we can have also heuristic. And then in silication. In sili. Okay, in silication. Okay, and then for mathematical approach, of course, if you referring to formal method is mathematical approach because it combine the mathematical formula and then to software and system development, we support rigorous specification, design, and verification of the computer system. This one is takes a lot of phases, okay, a lot of phases. That's why in a formal method is a complex system. It go back to complex system, very complex system because uh, it involves a lot of design, a lot of verification of computer system. Okay, do you have any questions so far? Oh, not yet. Okay, baguslah ni Amar ni. Okay, this one I have explained. Formal method, the techniques basically is the technique. how you want to calculate, how you want to calculate. Okay, basically calculate the risk. Calculate the risk to model up the complex systems such as mathematical entities. Okay, during a formal specification, an engineer or designer rigorously define a system using a modular language, typically by using a formal mathematical syntax and semantic that eliminate imprecision and ambiguity. This one is very, very important to have and to know. Okay, and then complex system that we defined earlier, like here, aerospace, automotive, is very complex. Okay, and then we have mathematical entities. Okay, okay, mathematical entities is very common in formal method. Okay, because according to the uh, uh, according to the conception of realism, mathematical entities such as a function, numbers, and set. Function, numbers, and set. Mathematical entities, function, numbers, and set. This one is mathematical entities. Okay, you need to define mathematical entities. Later, we are we are inventing the mathematical theories. Okay. Okay. What is the four mathematical representation? We can have the Cartesian graph. We can have also what is algebraic equation. We can have the number of lines. This one is mathematical representation. Okay. This one is more on the function. Function. Later we see this one is A is subset of B and B the power of subset of A and so on. Okay. Uh, do you have any question? Is it okay now? For now, is it okay? Is it clear? Clear. Can I take some note here? Boleh saya conteng-conteng ke tak boleh? Tak ada masalah eh? Okay. Boleh conteng-conteng eh? Okay, and then formal method continuation. Okay, it is based on the technique and tools. And absolutely, we are looking for the mathematical and formal logic. In here, we have a lot of inferences, inductive, deductive process. And then we can assume the various form and level of rigorous. They have leveling into four. First one, informal. Second is low, medium, and high. This one is various form of level of uh, uh, rigorous checking. Rigorous checking. Okay, and then also in a formal methods, but this one we are continuation for the model. We want to model the software based on the mathematical approach that are going to develop a complex system software system. And then the approach is using a formal specification language. Okay, formal specification language that have several several characteristic that can embed the mathematical equation. Okay. Okay. Other than that, a formal specification language, we can use the Z language. Z language basically is statement expressed in language that have some vocabulary, syntax, and semantic. Okay, this one is for the formal software, uh, formal specification language software lah. Okay, we have vocabulary. Okay, specification language. Okay, we have the vocabulary. Okay, and then we have also syntax and semantic. Okay, this one is very common in formal method. Okay, what is semantic? Semantic is uh, semantic meaning to the language or logic. Which mean here is basically referring to the logic. Okay, logic in a formal method. It's basically to understand. Semantic is to understand and determine the part of meaning which field that they are interested. For example, if we go for the engineering, we are looking for the engineering semantic or logic for the engineering. This one is based on the logic inferences, semantic. Okay, this one semantic is based on the logic inferences. Okay, okay next. Okay, do you want 5 minute break? Nak 5 minit break ke? Ah, tak nak? Oh, nah. Okay, we take five. We take five, and then we continue again. Because some of you are very exhausted, very tired. Okay, and in here I can saw some of you from my diploma students. Ada yang dapat di diploma ke? Ama memang daripada sijilnya, bukan daripada diploma. Lagi siapa? Syed Sulaiman Afif dengan Syed Muhammad Akif ni, kan? Kamu ambil projek pun dengan saya masa diploma. And then siapa lagi? Haikal? Bukan. Mariam? Bukan. Mariam bukan ke? Oh, patut macam kenal je. Semua dah dewasa Okay, we take five resting, and then we continue. Saya lagi lah tak ada rehat daripada pukul 8 tadi straight kelas. Sampai you all punya kelas ni sampai pukul 5 rehat solat je. Okay. Okay, radiation therapy. I'm sorry. Radiation therapy also very critical to treat the cancer. To treat the cancer because we need some rigorous punya application or techniques to be applied. Syafiq, macam kenal lah kamu ni. Kamu daripada saya pernah ngajar ke? Pernah? Bila Oh, sekarang kamu saya berapa? Oh, dah besar dah. Dah boleh kahwin dah ni. Zulaiha ada Zulaiha? Zulaiha? Nur Zulaiha ada? Nur Zulaiha Hasni? Oh, tak ada mikrofon. Okay, we rest 5 minit semua dah makan ke? Ke semua tidur ni? Ke ada yang ada ngantuk nak tidur ni? Malam tak tidur Okay, we rest 5 minit Okay, don't worry. If you have an internet connection, I will upload all the my lecture to YouTube. YouTube, and then if you are interested, you can subscribe or like. Okay. If you are not interested, you can dislike. It's up to you. It's not mandatory to see my lecture in YouTube. But I see the opportunity for you all because the YouTube you can scroll, you can forward, and you can see my lectures several times to to revise my lecture. Okay, kita dah 5 minit ke? Ke nak sambung? Oh, dah lima minit dah. Okay, kita we apa? We continue a little bit lah. Okay, and then after that, I think uh, uh, I go by explanation for this course. Okay, in a formal method in software engineering, we need to formalize. Okay, because formal method for formal method for software and hardware is motivated by expectation, which means that if you know more, you can expect more. Okay, what to formalize? This one is a very common question. Very common question because if you need to know for method, you need to know uh, what to formalize. Basically, this one is to performing appropriate mathematical analysis that absolutely we can know if we go by the formalization is the contribution for the reliability and also robustness of the design. Okay, basically, what to formalize? We formalize the design. Okay, we formalize the design. Design. Okay, okay, we formalize the design. Uh, Basically, this one for the reliability. Can you read my writing? Boleh baca ke? Boleh sorry for that tulisan cakap ayam. Okay. Uh, uh, okay, and then we also conclude that every formal method that we formalize, we need a model, model to design. This one after that we need to model. Okay, model because the model requirement knowledge. So from that we can reasoning about the model that we built or we created, specification of requirement so that we can document them precisely after we model. Uh, okay, we can infer and okay, infer and also we can document. After that we document. Okay, and then this one after that we can specification of the program design so we can verify the correctness. Okay, after that after we document we can verify the specification. Okay, okay, this one what to formalize? We formalize the design to create or crafted a model that can infer by the system requirement That finally the output of the inferences will be a document. From the document, we can specify the specification for the program design. Okay, this one is uh, we involve a lot of stages. And then for the stages, as we look back again, we have informal, low, and medium and high. This one from the informal. Okay, this one from the informal. Formalized phase one, informal, and then we go by the low. This one is low, and then medium, number three, and this one specification is high. Okay, this one is the leveling. Leveling. Okay, why we must formalize? You can read this one. First, his thing is to remove the ambiguity and improve the precision. Because this one, we are modeling a lot of the safety critical system. Okay, safety critical. Okay, and then to verify the requirement that have been met, this one specification based on the specification. Specification. Okay, basically this one from the model that we created. Okay, and then to reason about the requirement of design, this one based on the documentation. Okay, documentation. Documentation from here, from here from the high specification. Properties can be checked automatically. This one is the benefit from the documentation. Test for consistency, explore the consequences. Okay, this one after we have the documentation. And then to ensure the quality is also important. And then fourthly, to animate or execute the specification, have to visualize and validate. Okay, visualization. This one on the more on the graphical notation. Okay, and then lastly, because we have to formalize eventually anyway, because of the bridge of the informal world to formal machine domain. Okay, from the unknown modeling to known modeling that can be understood for human. Okay, this one informal world, a formal machine domain is very hard to understand. Okay, we need to translate. Translate or formalize. The other name is to translate. Okay, to translate for understanding. Okay, okay, next. Okay, here is formalization. Why we must formalize? This one is basically based upon the discussion of benefit or advantage. Okay, this one based on the advantages. Okay, next is why people don't formalize. This one more upon the disadvantages. Okay, disadvantages. Okay, formal method tend to be lower level than other techniques because it infer the low level uh, uh, languages. Okay, and then it also includes too much detail. Too much detail here, which means that too much process. Process. This one is more on the process. Processing. Processing of inferences. Okay. Okay. So far, do you have any question? Is it okay? Boleh ke? Syawal, okay? Is it okay for you? Tukar color. Color kita tukar. Read lah, sebab ramai mengantuk ni. Okay, and then formal method also focusing on the consistency and correcting the model. Okay, most of the time your model are inconsistent, incorrect, or incomplete. Okay, because of the behavior of the system, behavior of the model. This one model because of the behavior. Okay, some people got confused about the tools that are appropriate because in formal methods you have seen a lot of program behavior, a lot of modeling that advocates some of the followers to get touch upon one tools. This one is more on the uh, knowledge that you know lah. Okay, some of the people get to know more on the behavior. Some of the people get to know more on the modeling. Okay, and then formal method require more effort, and this one takes uh, a lot of money lah because it takes a long time, long time. Okay. And then this one is more on the traditional formal specification languages that have been used in safety critical system. Okay, and then example of the program design closely tied to program the semantic. We have LAS, we have Z notation, we have Vienna development method, and so on. This one is a program. Later here we see only two, Z notation and VDM. Okay, this one only two program that we see in this course. Okay, and then we have reactive modeling. Reactive modeling basically is the higher level modeling that basically involves the system behavior, and then it is also involve a reactive system like a real-time embedded control system that can be a valid reasoning for the safety, liveness, and performance. Okay, the key point here is consistency and model checking. This one is very important because you have the model. Okay, you have the documentation. Okay, and then you need to have the model checking and consistency checking. Okay, for this one, you can see we have a state chart. Okay, this one is more on the modeling and designing the state. Okay, and then we have RSML, partner stable, and SCR. This one is famous reactive system modeling. Later we see this one in chapter 8. Okay, and then for formal conceptual modeling, we can have the predicate logic as underlying formalism, and then we can have also a knowledge base, and then this one example we have Rex Apprentice, RML, uh, Telos, Albert 2, and so on. Okay, and then this one is we go back again for the low level. We have first one formal specification, formal proof, checking, and abstraction. Okay, we go back again for the leveling that we discussed before. Okay, for the formal specification, it's basically direct translation from the non-mathematical equation or description. Basically, we are looking for the diagram. We have a table and natural languages into a formal specification language. This one is the translation. The translation is being done by the human, and then need to translate with the software itself. And then it is important to know that every translation is translated correctly. Okay, this one for formal specification translation. Okay, and then we have specification. Okay, the formal specification example. We can have the method to modeling the complex system such as mathematical entities lah. Okay. Okay, and then for formal specification, we are looking into the informal specification lah. Okay, for the formal specification, is basically for the programming language lah. Okay. Okay, programming language such as C, C++. For informal specification, we can take a look such as UML model. Okay, we have two type here, formal and informal. Okay, formal and informal. For formal, we are looking for the specification for programming. Okay, and then for informal, we are looking for UML. Okay, when you talk about a formal specification, it represent or acknowledge the concise description of high-level behavior and property of the system. This one is basically for the syntax. Okay, and then a well-defined language (WDL), semantic support formal deduction about the specification. Okay, this one formal specification. Later we see this one formal deduction. Okay, and then type of formal specification. Basically, this one is including the programming. Programming. We have the state chart, SCR, VDM, ZAG, and then we have a Patrinet. This one is modeling the system behavior to model the system behavior. System behavior. Okay. And then the property oriented, this one use the necessary property to describe the system behavior based on the model that we develop, such as axiom rule and etc. We have two here. First one is algebraic semantic, and secondly is temporal logic model. Okay, both here is a very rigorous process. Is very rigorous because we need to have some basic understanding for the algebraic semantics. Okay, because in computer science there are two definition here. First one for the computer science we have algebraic semantic, and the other one we have the mathematical logic. Mathematical logic semantic. Okay, for the mathematical logic semantic is more on the axiom semantic based on algebraic law. Then that describing the reason about the progress semantic in formal manner. Okay, algebraic semantic in formal manner. Okay, this one is more on the formal manner. Formal manner. Okay, algebraic semantic. Okay, this one basically we go by the mathematical approach. Okay, mathematical approach. Okay, we are not discussing more about the algebraic semantic because this one we have studied in the uh, discrete structure subject. And then for this one, algebraic semantic, we also use the abstraction data type ADT. Later we discuss this one ADT. Uh, ADT, formal manner. Example, we have ADT model, abstraction data type model. Okay. And then secondly, we have a temporal logic model. And this one is supplementary for the temporal logic model. Okay, this one is a very common technique that known the convert the okay temporal logic. Okay. Yeah, basically, for the temporal logic model, we convert the method to have output lah, output. Okay. Okay, temporal form method in a formal logic. Okay, basically is the extension of a classical logic lah. Basically, the temporal logic has been used in linguistic. Linguistic. Okay, this one basically used in linguistic. Okay. Okay, and then we go by the formal proof is essential part of specification because we have discussed this one as a part of documentation. Okay, proof are constructed a series of small steps and then a lot of series that justify using a small set of rules. Okay, this one we are learning for the next week. And then proof can be done manually, but usually constructed with some automated assistant. Okay, some automated assistant, we discuss this one later because automated assistant basically form based on the logic. Okay, based on the logic. Okay, and then that's why we go by the model checking. Model checking, we have a temporal model checking and automated model checking. Okay, for the abstraction, ADT. Okay, abstraction data type. Okay, represent program with a smaller model. Okay, and then we use the mathematical model. Okay, we have two type here. First one is continuous modeling, and second is discrete modeling. Okay. Okay, this one is the formal specification process model. How you want to clarify the stages in every stages. Here we have one, two, three, four, five, six stages that you need to complete in order to attain the complete or success model. Okay, this one is just a limit of formal method. What is the limitation? Okay, and then okay, as a conclusion, system will never 100% secure. This one is the fact that you need to think because all of the system need update every time we need to enhance our system and then the formal method will not break this axiom or this rules axiom or rules is the same okay and then we need some assumption firstly that formal method is hard to state explicitly because this one we need to model we need to have a system behavior is differently okay wait we rest 5 minutes hello salam ya Faina ya ya uh, gini sebab dia punya limit untuk saya punya apa saya punya grant tu 2,500 sebab yuran untuk apa jurnal tu mahal sangat. Yelah tak apalah luluskan 530 pun tak apa 520. Oh, jadi tak boleh. Amount dia sebenarnya 1,000 tapi oleh kerana profit dulu sebelum hantar jurnal kan. Jadi jurnal tu harga dia mahal. Jadi bila saya nak claim Uh, Sebenarnya kalau 1,000 je kan saya boleh claim untuk jurnal. Okey, terlebih. Hmm. Oh, dia tak boleh terlebih. Ah, tak boleh ke macam tu? Tak boleh. Jadi macam mana? Okey, nanti dia tolak macam mana? Oh, note macam tu je lah. Ah, ah. Okey. Okey, nanti saya okey, nanti Farah bagi email, saya email kat Farah ke macam mana? Apa email Farah? Abang Farah? Oh, oh panjangnya. Sekejap saya ambil ni sebab saya tengah kelas ni. Tak apa, NOR okay, edu. Nur Farah Suria. Okey, nanti saya emailkan secepat mungkin lah. Itu je kan, tak ada apa lagi kan? Ya, yang note tu minta tolong Puan Farah ni take note sikit. Okey, terima kasih banyak-banyak. Assalamualaikum. Okay, sorry for that. So far, any question? I think we have finished our lesson today. Okay ya? Ke tak okay? Uh, if you don't understand, you can ask me. Later, I will upload all of the my